Hey there, welcome to our whirlwind tour to the fascinating world of stress in the brain, where our body's nervous system gets into some serious action and sometimes things get a little, well, stressed out. Imagine your body as a superhero team, always ready to spring into action when danger appears. That's where the nervous system and the autonomic nervous system come into play, triggering the famous fight, flight, or freeze response. When the stressor shows up, a looming deadline or a snarling dog, your hypothalamus, the brain's command center, kicks into gear, activates the hypothalamic pituitary adrenal axis. This axis starts with the hypothalamus releasing corticotropin, releasing hormone, which signals the paraventricular nucleus to send a message to the pituitary gland. Pituitary then releases adrenocorticotropic hormone, traveling to the adrenal medulla, prompting it to produce stress hormones like epinephrine and norepinephrine, also known as adrenaline and noradrenaline. These hormones crank up your metabolic rate, raise blood pressure, accelerate respiration, and prepare your muscles for action. Here's where it gets intriguing. This stress response isn't just a quick burst, it also involves a cascade of hormones like cortisol, the body's main glucocorticoid. Cortisol helps mobilize energy, but it also affects your brain, especially regions like the hippocampus, amygdala, and prefrontal cortex, all key players in emotion and cognition. Hippocampus is your brain's memory librarian, and amygdala is the emotional alarm button. Now, prolonged exposure to high cortisol levels, like in chronic stressor conditions such as Cushing syndrome, can lead to neuronal loss, shrinkage of hippocampal volume, and even neuronal death. This isn't just science fiction, it's been observed in neurodegenerative diseases like dementia and in mood disorders such as depression and PTSD. It's not all doom and gloom. The brain is surprisingly adaptable. Structural plasticity allows neural and glial cells, the brain support crew, to remodel, repair, and sometimes bounce back from stress-induced damage. Neurogenesis, the birth of new neurons in the hippocampus, is a shining star. Neurotropic factors like brain-derived neurotropic factor promote this process. Antidepressant treatments often aim to boost neurogenesis to counteract the effects of stress. On the cellular level, chronic stress can lead to glial changes. Glia are the brain's immune cells and support network. Microglia, the brain's resident immune cells, can shift from a peaceful tissue repairing phenotype to an inflammatory amyloid state under stress. This neuroinflammation contributes to mood disorders and neurodegeneration. Inflammation involves cytokines and interleukins, which can further disrupt neuronal function and neurogenesis, creating a vicious cycle. So what can we do? Well, practice like mindfulness, emotional focus, coping strategies, and maintaining a healthy work-life balance can boost your psychological flexibility and stress resilience. Skilling your brain in spotlight, reducing perceived stress, promoting better emotional regulation, supporting plasticity. Stress is a natural and essential part of life, helping us stay alert and motivated. Too much stress, if chronic, can lead to structural and functional damage. So take a deep breath, relax, remember your brain's got this, especially when you give it some love and care.